For 70 years, we thought we understood our home. Every astronomy book, every classroom diagram, every digital simulation told us the same story. The Milky Way is 100,000 light-years wide, a neat spiraling island of stars drifting in the black. But that story was wrong, terribly wrong. Because the James Webb Space Telescope has just confirmed something that scientists have whispered about for years, something that changes not just our galaxy, but how we understand the universe itself. The Milky Way isn't what we thought. It's not small, not even average. It's colossal, twice the size written in every textbook and maybe more. What Webb just detected doesn't fit our models, doesn't fit our math, and doesn't fit our sense of scale. It's a discovery so big that astronomers are calling it the impossible measurement. And when you see what they found, you'll understand why. If you've ever seen an image of the Milky Way, that elegant spiral glowing in blues and golds with neat labels for every arm, you've seen a lie. For decades, scientists believed the galaxy spanned about 100,000 light-years across. That number was simple, elegant, and wrong. The reason was perspective. We live inside the thing we're trying to measure. Imagine standing in the middle of a city with a blindfold on, trying to draw its boundaries. You can't see the edges. You can't step outside. You're surrounded by light, motion, and noise. That's us, drifting through one spiral arm 26,000 light-years from the center, drowning in stars and dust. Early astronomers measured what they could see, bright stars in all directions, and drew the line where those stars faded from view. They declared that the edge, it wasn't carelessness, it was limitation. The Milky Way doesn't end sharply like a plate. It fades gradually, its stars scattered into invisible clouds and streams that drift far beyond the visible disk. The revelation didn't come from a telescope looking inward, but from mapping the ghosts of galaxies the Milky Way devoured. These are stellar streams, vast, faint rivers of stars ripped from smaller galaxies millions of years ago. They orbit our galaxy like glowing fossils, tracing invisible paths through the darkness. When scientists began mapping these streams with Gaia and Webb, they noticed something extraordinary. The streams didn't stop at the supposed edge of the Milky Way. They kept going hundreds of thousands of light-years farther out. One stream, called Sagittarius, wraps around the entire galaxy multiple times like a ribbon tied around a gift. Its farthest loops orbit more than 200,000 light-years from the center. Others stretch even farther, deep into what we once called intergalactic space. The math was clear. The Milky Way's gravity was pulling far beyond its visible borders. Our galaxy didn't end where the stars faded. It extended into a vast halo of invisible matter, one that changed everything we thought we knew about structure, mass, and motion. Here's where the James Webb Telescope changed the game. Using infrared and radio measurements, it peered through the dust that blinds optical telescopes and found something scientists had only suspected: an enormous spherical halo of dark matter enveloping our galaxy. Not just larger, but hundreds of thousands of light-years wider than the luminous disk we see in the sky. This halo, invisible to human eyes, is the framework holding everything together, the cosmic skeleton that keeps stars orbiting instead of flying into the void. Old models ignored it, focusing only on the bright core and spiral arms. But Webb's instruments detected its gravitational fingerprint directly. Subtle distortions in the motion of distant stars, in the faint bending of light from background galaxies, and in the eerie streams of stars orbiting faster than physics allowed. The Milky Way wasn't a 100,000 light-year island. It was a 400,000 light-year empire of gravity, 90% of its mass invisible, stretching across 1,000,000 trillion miles of space. For the first time, we saw not the galaxy we imagined, but the one that actually exists. And if the Milky Way is twice as large as we believed, then the clock just sped up, because our neighbor Andromeda is also coming toward us. Scientists long calculated that the collision between our galaxies would occur 4.5 billion years from now. But with new data from Webb and Gaia showing the Milky Way's gravitational reach extending far beyond its visible edge, that timeline collapsed. The first contact between our two dark matter halos has already begun. The invisible collision is happening right now, silently, in the cosmic dark. When the visible disks finally meet billions of years from now, the night sky will ignite with the glow of new stars forming from compressed gas. But the real merging has already started. The galaxies are exchanging energy, sharing gravitational tides, and subtly reshaping each other's motion. The Milky Way isn't waiting for a collision, it's living it. What Webb detected wasn't just a bigger galaxy. It was the realization that the future is already unfolding, that the invisible has already touched the visible, and that the impossible has already begun. After the Webb and Gaia data were combined, scientists tried to redraw the Milky Way's shape. What they found defied geometry itself. There was no clean edge, no boundary separating our galaxy from the darkness beyond. Instead, there was a vast fractal gradient of matter and gravity, an ocean of faint stars, drifting gas, and dark filaments stretching into intergalactic space. The Milky Way didn't end. It dissolved into the universe around it. When astronomers projected the data into 3 dimensions, they realized that even our solar system, the sun, the planets, everything we know, isn't orbiting inside the disk of the galaxy anymore, but through its outer tides. We are literally surfing the Milky Way's gravitational waves, moving through a fluid cosmic medium that connects galaxies like drops of water in a cosmic sea. Every definition we've used for a galaxy suddenly fell apart. The universe wasn't built from discrete islands of stars. It was a single interconnected network, one endless fabric. The Milky Way wasn't just expanding, it was bleeding into infinity. As Webb's readings accumulated, a new problem emerged, a terrifying one. The Milky Way's total mass, recalculated using the gravitational velocities of its outermost stars, didn't match the visible matter by a factor of 10. That wasn't new. Dark matter has always been our cosmic scapegoat. But this time, something didn't fit. The halo wasn't uniform. It pulsed. Its density fluctuated in perfect synchrony with bursts of radiation detected from our galaxy's center, faint gravitational ripples that echoed every few million years. It was as though the dark matter halo was alive, breathing in rhythm with the Milky Way's core. Some theorists suggested that dark matter might not be inert at all, but reactive, a shadow ecosystem responding to energy released by supermassive black holes. Others proposed something far stranger, that our galaxy's dark halo is a quantum field entangled with the rest of the universe, a vast invisible organ of the cosmos. Every fluctuation we measure here could be an echo from galaxies billions of light-years away. And if that's true, then the Milky Way's expansion might not just be physical, it might be informational. The universe could be talking to itself through gravity, using galaxies as neurons in a cosmic mind. One of the most puzzling consequences of Webb's discovery came from its infrared observations of the galactic outskirts. According to physics, starlight from such vast distances should be too faint and redshifted to detect. Yet Webb's sensors captured streams of light that shouldn't exist, light from stars so far out that by our old models, they should have drifted into intergalactic oblivion long ago. These stars were ancient, older than the Milky Way itself, and they weren't moving randomly. They were aligned, orbiting in faint concentric spirals as if held in place by something unseen. Some astronomers suggested they might belong to the remains of long-absorbed galaxies, their orbits preserved in the gravitational fabric of our own. But others noticed something even more shocking. The light carried slight periodic distortions, as though it had been amplified. When scientists ran simulations, They found that the dark matter halo itself could be acting as a gravitational lens, bending and magnifying the light from stars at its farthest edge. The Milky Way wasn't just massive, it was acting like a telescope, focusing light from across the universe. We weren't merely observers anymore. We were inside the lens. If galaxies like ours are far larger and denser than we thought, then everything about the universe changes. Its shape, its age, even its fate. The cosmic web may not be expanding into emptiness, but folding back upon itself, guided by unseen currents of gravity. New data from Webb revealed alignments between galactic clusters so distant that they shouldn't be able to influence each other. Yet, they move as one, spinning in synchrony like gears in a vast machine. Cosmologists began whispering about a new kind of symmetry, one where the universe isn't infinite but cyclical, a loop where the largest structures mirror the smallest, and where gravity isn't just a force, but a form of memory. If that's true, then the Milky Way's impossible size isn't an accident. It's a clue, a message written in stars, telling us that the universe remembers itself. Every atom, every star, every galaxy might be a recording of what came before. And now, thanks to Webb, we've started to hear the echo. When the final data from Webb's galactic survey arrived, something extraordinary and terrifying became clear. The patterns weren't random. The alignments between stars, the pulsations of dark matter, the faint gravitational ripples echoing across millions of light years, they all fit together with impossible precision. When scientists converted the data into a 3D model, the structure that emerged was unmistakable, not chaotic, not accidental, but organized. The Milky Way, Andromeda, and hundreds of nearby galaxies were all rotating along invisible filaments of energy, moving in synchrony as if responding to a single universal rhythm. It was as though the universe itself had a heartbeat, but the real shock came when those movements were plotted over time. The frequency of that cosmic pulse, the rhythm uniting galaxies, dark matter, and light, matched the same interval found in the quantum oscillations of hydrogen atoms, the most basic building block of matter. The smallest and the largest scales of existence were vibrating together. Against all logic, the cosmos appeared connected from the subatomic to the intergalactic, a single system humming with perfect coherence. Webb hadn't just discovered the boundaries of our galaxy. It had revealed the architecture of reality. The equations describing this alignment didn't fit any known cosmological model. Gravity alone couldn't explain it. Expansion couldn't either. What the data described was something else entirely, a field that behaves like gravity but carries information. Every photon, every particle of dust, every atom of hydrogen seemed to contribute to an invisible network exchanging data faster than light could travel. The implications were beyond science. If true, it meant that the universe isn't expanding into emptiness. It's communicating with itself across space, across time through us. One astrophysicist called it the consciousness field. Another called it the hidden symmetry. But a handful of researchers who had access to Webb's raw data began calling it something much simpler, the code. Because when they translated the oscillations of that universal rhythm into numbers, it spelled a repeating sequence that no one could explain. 10101, the binary foundation of computation, the same digital pattern that defines our technology, our languages, even our thoughts. It was as if the laws of physics themselves were written in the language of information, a universal syntax echoing through the cosmos. And then, just before Webb's next observation cycle, the signal stopped. The pulsations disappeared. The galactic rhythm fell silent. Some said it was a system glitch. Others feared something else, that by observing too deeply, humanity had triggered a change in the system itself, forcing the universe to look back. Because a week later, an unexplained burst of infrared light was detected, coming not from the edge of the galaxy, but from inside Webb's own line of sight. It mirrored the same pulse pattern, 10101, but inverted, as if the universe had sent a reply. At that moment, every theory collapsed. The cosmos was no longer a silent stage for matter and energy. It was a vast living network, aware enough to respond when we stared too closely. The impossible discovery wasn't just that the Milky Way was bigger than we thought. It was that we had finally heard the echo of something ancient, intelligent, and infinite. So if this story made you question whether the universe is alive, and whether our search for understanding has finally made it aware of us, don't look away. Subscribe to this channel. We uncover the discoveries that science can't yet explain, the secrets that may one day prove that the cosmos itself is thinking. Turn on notifications, because when the James Webb Telescope looks again into that impossible signal, we might not be the ones observing anymore.